you walk them in the morning?
Yeah, she's a puppy. She can't be like not have exercise in the morning as well.
Oh no, there's a hole in my pencil pouch. There's a hole in my pencil pouch.
Oh no. Okay, so let's talk about 5 and 6.
Yeah.
So they're talking about 2 different types of baseball bats. And you don't really have to know anything about baseball bats other than all the vocab that goes along with them. It's kind of annoying in this case because it kind of goes over your head a little bit in terms of they're talking about finishing the baseball bats or. So talking about number 5, it says the wallbanger and the dingbat are the 2 bats. The wallbangers take 8 hours to trim and turn and 2 hours to finish, and has a profit of 17. Dingbat, 5 hours to trim and turn, and 5 hours to finish, but the profit is 29. Total time available is 80 for trimming and turning, and finishing is 50. So the unknowns are the bats. So our W and what's the other one? Wallbangers and dingbats. Sorry, D. Wallbanger and dingbats are 2 bats. They talk about, they want you to basically write an equation. It talks about, it says write a system of equalities that talks about the wallbanger and dingbats that can be produced per day. So we need to talk about how long it takes to trimming and lathing. That says the maximum time per day is 80 hours. So we have to stay under 80 hours for the trimming and finishing, or trimming. But they tell us the wallbanger can be trimmed in 2 or 8 hours, 8W, and the dingbat is 5 hours. And then the finishing, you only have 50 hours to do that. And that one takes 2 hours to finish on the one and 5 on the other. And I should have suggested this to you guys. I would suggest doing this using intercepts rather than slope-intercept form. Do you guys remember graphing by intercepts? We could find the zeros of the functions. That would allow us to find, or not the zero, sorry, where each of the axes ends up being 0. So let me show you guys what I mean. So if I find like the W-intercept, that's where the dingbat is 0. So I'm going to put 0 in for D. That makes this 0, so I get 8W equals 80, so that's going to be 10, 0. Then I can do the same thing for the other half of it. So the D-intercept is where the wing and the wallbanger is 0, so this is going to be 0. So 80 divided by 5, so that would be 16. So 10, 0, and 0, 16 are the 2 points I'm going to put on my graph for this first function. This would make graphing this a lot easier. And I should have mentioned this, and I didn't think of it when I was doing it until later. So I'm going to go over to 16. 2, 4, 6. I don't know if that's going to work. So let's go 4, 8, 12, 16. 4, 8, 12, 16. So this would be 4, 8. So 10 would be here. We have 10. We have 16. Or no, it was the other way. Sorry. So the W-intercept is 10. So right here. The D-intercept is 16. So here's my first line. I can do the same thing for the other equation. So put 0 in for D. So 2W equals 50, so it's going to be 25, 0 for the wingbat, or the wall banger. And the other one's going to be 0, 10. 25, so this is 16, this is 20, this is 24, so 25. This is 10 over here. All right, it's a really bad line. There's our other line. So we have to kind of figure out that intersection point, because all the shading should be under here. Those are the bats where the bats actually make sense. So that looks like it's about, what is that, 4, 8-ish? Yeah, 4, 8. And they say 5 and 8 when I look at the answer key, so 4 and 8 is probably pretty close depending on, and we have to then put that into our equation for our profit. So it tells us we make $17 on the wall bangers and $29 on the dingbats. 17 wall bangers plus 29 dingbat, I'm gonna put those values in. So I guess to spare us a little bit of time here, I'm not gonna do number 6 for us right now. Again, what I ended up putting on the test is more one similar to what we had in the back of the book, where I give you guys inequalities, you have to shade that in, and then you have to pick those points around the edges and test them. So I'm gonna stop for now, just because I want to give us some time to get through our notes and make sure we're comfortable with that. So you guys can set that aside. Put you guys your notes out today. I'll tell you one of the things I really like about math and solving equations is when I take a ton of time to solve an equation and it all works out super nicely. And these types of equations, I have to grab one more. These types of equations are those where like they're gonna be long problems, but they're kind of satisfying when you come up to a final answer.
I'm counting on you for saying that.
You're organized, Abby, so you'll like these.
She thinks I'm
People who aren't
organized.
organized may not.
Okay. Let's say half.
If you haven't done so already, you guys can look at the warm-up question. I don't know why.
No one noticed the mess up on the agenda. Let's finish homework and supposed to say finish notes.
So he wants to solve the warm-up by elimination. You notice our examples here today, we have 3 for our notes, and that's because they are long problems. All right, so if you get working on the warm-up, they want you to add or subtract those equations, but you're probably going to have to multiply by something first to make it cancel. So in this problem, to solve by elimination, you're going to notice that you have to multiply by more than one value, because most of us don't want to work with decimals. And so multiplying by a decimal sounds like a bad idea. So we want to make something cancel in this for elimination. So what did you guys notice that you could make these match up as? 15. Yeah, so 6 and 8 are a little bit bigger numbers. So the 3 and 5, hopefully you notice that you could make this, so kind of like what I want, kind of my dreams over here. 15y and a negative 15y or vice versa, right? That's what I realized here. I can make that happen. Or wherever you want the negative to be. So in order for that to happen, what do I have to multiply the top by?
-5.
Okay, so did you do a -5 on top?
I did.
Does anyone disagree with her? You can go. Okay, thanks for being a
Jordan.
So -5 on top. Now, so we're gonna flip this, that's okay. And then what are we gonna multiply on the bottom?
3.
3. So kind of looking at what we wanted, we made kind of the choice onto what multiplication we needed to do. Does that make sense how we chose those numbers? And you could also chose like 24 or 48. Yep.
I think it would be easier. Thirds.
Really? You want to multiply by 2/3?
No,
Yeah, 'cause
don't do it
I-
that
oh,
way.
oh,
Ryan,
yeah,
stop.
yeah,
Stop.
Plus, negative.
If you guys want to go with Ryan's route, go ahead. Like, but I like even a math teacher who's not afraid of fractions, that kind of likes fractions. I would not choose to do that. I'd be nervous I'd do something wrong. But if you'd like to do Ryan's method, it also works. So there was a big smile underneath my mask, like for that. If you'd like to do it that way, that's fine. More power to you, Ryan. Good work. So
Extra credit.
yeah, you get a little gold star for doing it the hard way. Okay, or the easy way for you to know. So I multiplied everything by -5. I like working with whole numbers if I can choose those. On the bottom, multiply everything by 3. And then I'm ready to add. And now my equations will cause that 15y's to cancel. Add this, I get a -6x. And then this will be a +6. And then I'm able to solve this with a one-step equation here. So x ends up being a -1. And once I know that, I can put that back in to find my y, into any of these original equations. Just because this one's right here, I'm going to put it here. So y ends up being 4, right?
Yes.
All right, so if you like solving by elimination, today's gonna be good for you. If you don't, sorry. I don't have much for you then. You're gonna be unhappy
Suck
with me.
it up.
Yeah, you're gonna have to get tough. So we're gonna talk about how to solve a system of 3 equations. So now there's 3 variables and 3 unknowns. Now we're gonna start easy-ish. We're gonna start easier and then work our way a little bit tougher.
Z.
So if you have 3 variables, you need 3 equations to solve. So if we don't have 3 equations, we can't solve 3 variables. Just like 2 variables, we need 2 equations. Now this first one is, like I said, is kind of an easier level in terms of scale of difficulty. Because if you look at the 3 equations, the last one kind of gives away one of the answers. It tells us z is 2. So it's nice of them to give us that. We can kind of work our way backwards. So if z is 2, I already have 1 out of the 3 variables solved for.
Yeah.
What can I do with that?
Plug it in for every Z.
Yeah, we can plug it in for z. And I would suggest going just like one step back. So I'm just going to plug it in here right now because I want to figure out what y is. And that one has 2 variables. So y ends up being 3. Now I have y and I have z. So I can go back to the top equation. I should be able to find x. Because I have 2 out of the 3 variables. So y and z I know. And I'm going to be able to find x. So this is just kind of getting our feet wet in this 3 variable idea.
Feet wet.
And then we're going to jump all in.
Did that just get greater? No.
What?
I thought the light went. Maybe it's just my imagination.
You need water.
You need water. Quick water. So we go from easy to kind of get into like the fast lane here all of a sudden. When I first learned how to drive, my driving instructor tricked me into getting on the freeway. Like we were on some weird road, kind of like near Kewaskum. It wasn't there, but if you're like driven in Kewaskum by like Sunburst, and all of a sudden you're driving on like just a regular road and it becomes the freeway.
Oh, yeah.
Like, so that's what he did to me. So I feel like this is what we just have done. So we're like driving on this nice country road and then like freeway. So here we are.
Oh,
We're on the freeway,
sweet.
cruising along.
We merged.
You better get your speed up.
Your third husband at first.
Oh, my third husband.
And I was like, I thought she only had one.
Yeah. I
Where-
have plans.
Learn more about it.
Yeah. All those marriages. Oh, do you want me to go back?
Yeah.
Sorry.
I can't wait to go outside. I don't know if I can fall asleep.
Okay, yeah, so let's go through, we'll do this one and we'll go outside for a bit. We'll take a little walk and then we'll come back in and do the last
And then
example.
we'll get the last one.
Okay, we're good?
You go get your
From the
blanket.
third.
You gonna go get your blanket again?
No.
It's nice, huh? Okay.
Yeah, it's 70, Maddie.
All right, guys. So hopefully you guys notice, like looking at this equation, is there a variable that looks like it might be easy to get rid of right away? Anyone see it, Ryan?
Top one.
A variable.
Oh.
There's not a top variable. Thanks. Okay, what do you think?
Y.
Y. So the Y looks easy to get along. Hopefully you guys agree with him on that. The idea that they all have the same coefficient and they have like a positive and a negative version, I would really like to find a way to get rid of one of the variables out of the 3. We know how to solve 2 variable equations. So we want to take this from 3 down to 2 if we can. And we want 2 equations with 2 unknowns. So what we're going to do is we want to get rid of, like choose to get rid of one of all of the variables. So we're going to choose to get rid of Y because that looks easiest because of the coefficients. So we're going to add these 2 together first to get rid of Y. And I'm just choosing that because I can tell the Y will already go away. So what do we get to get rid of Y here? So these cancel. I'm going to try not to draw too much all over the top so it's not a big mess here. But to add the X and X, we get
2x.
2X. The Y should cancel. Add the 3Z and the negative Z.
2z
2Z
is equal to 14.
equals 14. You guys okay with that? So the top and the middle equation gave us that.
Yeah.
Now, if I want to solve for these 2 variables, I need 2 equations that have those 2 variables in it. So I need to make another equation that has just X and Z in it. And we haven't used this bottom one yet. So I somehow want to use this bottom one to also get rid of Y. Anyone have an idea what one I could use it with?
The top one.
So some of you are pointing and others of you are telling me. I heard the top one because this one and this one together would also cancel a Y. Does that make sense? Those 2 together would get rid of a Y as well. So I'm putting the top and the bottom one together.
Come on.
We have X and 3X's. How many X's?
4x.
4X. The 2Y and negative 2Y cancel. 3z and a negative 5z.
Negative 2z.
Negative 2z. The best is when it's 1z.
Just z.
Oh, so it's 1z, like a 1z.
Oh, ha 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 ha.
1 and 3 is 4.
I thought you meant like 1z, and I was like, oh,
Yeah.
the z?
Yeah,
Okay.
that did mean 1z. Trying to be funny too.
I didn't register in my brain.
Okay, so we now have it down to 2 equations with 2 unknowns. We know how to solve this. This is something we've known how to solve since Algebra 1. So at this point, we change this problem into an easier version of this. So are we okay with where we're at right now?
Yeah.
2 equations, 2 unknowns. If I add these together, what happens?
The 2's go away.
Yep, the z's go away. So this is really good. Now we got down to just a single variable. 2x, 4x's, 6x. 14 and 4 is 18.
8, 10? What?
So we're able to solve for our x value.
I thought you did. But you said 8, 10. I thought 18.
So x ends up being 3. Yep, now we have to work our way backwards. So now we know x, but I'm not going to take x and put it all the way back in one of these original problems. I'm going to go one step back. So I'm going to go back to one of the ones that only has 2 variables. Like putting it in there so that I can figure out what the z is first before I try to figure out y and z at the same time. So we have 2 times 3 plus 2z equals 14. So I'm just choosing the top equation because it has positives rather than the negatives. So I get 2z equals 8 here. So z ends up being 4. And then once I have x, once I have z, now I can go back and find y. I'm just going to use the bottom equation. It doesn't really matter which one I use. So I'm putting these back into the bottom one now. Writing some like terms here, moving this over. So y ends up being 7.
What did I do? I got 29.5.
Oh my gosh. Yowzers.
9.
That should be a negative 20.
But then I added it. Oh, it's a 3, not a 30.
All right, so I think we need a little break. We're gonna go outside. Do you guys want to do would you rather or go for a walk?
Would you rather?
Okay, we'll go out.
Let's do both.
Sit on this side.
Walk around this block.
Okay, you're kind of right. It's kind of satisfying, but not when I add a 0.
I was trying to do the.
Did you see it?
What's that?
I was trying to do the last one.
Oh, and you got stuck. Yeah, so we need a break, yes.
Did you see? I messed up on the agenda and no one noticed.
What did you do?
I wrote finished homework, but I didn't write finished notes. Kinsey, why are you doing that? You're supposed to show my imperfect side.
You have one?
Fine.
That's so.
Keys.
what you missed out in Glee.
Here's what you missed on Glee. There's killer ladybugs outside. They wanted to kill us all. It was so scary. We found out Jax has this,
Yeah, I'm behind you then. I don't know if I ever was actually.
and then we also found out that Maddie has, 3 brothers.
I think I'm gonna do
According to Garrett, I have 3 brothers, Brad, Drake, and Daniel.
Oh, and I just
Yeah.
Welcome back. Actually,
Oh, I had it going the whole time.
sorry guys.
Oh,
Sorry.
I just learned in there.
Hopefully you fast forwarded when we were
Right back.
outside.
I said, and this is what you missed on Glee.
Just like.
What?
Kind people are my kind of people.
All right.
No.
So, you guys, the last question. I feel bad. Sorry we left you. Sorry. So,
10 minutes.
yeah. Hopefully you fast forwarded when no one was on the screen. Okay, so guys, this last one, it requires that you're specific about which one you go for or which equation you go after. You can't just say, like, that one looks easy to cancel. So you might look at this and say, well, I'd like to cancel the x's up here. I'm going to tell you guys right now, you're not really going to get yourself to a spot that's very helpful.
Sweet.
So what I would do is look at the equation that only has 2 variables here. That one has an x and a y. So that's already kind of telling us which way to go with this. Does that make sense? So this one is already missing what?
Z.
Z. So it's missing z. So I want to find a way to make z missing up here. So I want to use those other equations to get rid of z. Because I want to work with this equation that's already simplified or already like smaller for me. So how would I get rid of z in the top 2 equations? What kind of 5?
Negative.
Yeah, we're going to multiply this top equation by a -5 so that I can get rid of the z. Does that seem to make sense?
Yeah.
Zero times 5 is just 0. So again, we chose that because of the fact that they already gotten rid of the z in the other equation for us.
I think we lost someone outside.
Who?
Wait a second.
Who? Ben. Ben, it was
Oh,
Ben.
Ben is right there.
I thought we left you
Ben,
outside.
Garrett was concerned about you.
I
Yeah.
thought we left you outside.
You just read with the freshman.
Oh no, we left Ethan outside.
Oh, no.
And he headed to Nebraska.
Yes.
All right.
When
So,
does he come back?
I think he said he's gone all week. I don't know. He was unsure.
Huh.
Kind of sounded like a kidnapping, but whatever.
Wedding, I think.
All right. So the z's cancel there. So I'm left with I'm adding these guys together. So -5x and -x is going to be a -6x. -3y. And then 3. So now I have these 2 equations with 2 variables, but it's good because I have the same 2 variables in 2 equations. So any thoughts on how we can make these 2 come together and do something good here? By, I don't think you need a negative. What did you want to multiply by? Sorry. By 2, yeah. So we can choose now to either get rid of the x or the y. And I think what Kinsey said the first time, but sometimes the math is a little bit tough. She suggested multiplying by 2 here, because then this would be a 6x, and that's a -6x. Or you could also choose to use the -3, either way. So if I do 2, so 6x, we're going to multiply by everything. So we had to do a little bit of thinking more than just combining equations here. This is a -5y. This is 15.
I can.
This ends up being a -3 here. Now that I have that -3, I can work my way backwards. So I know what y is. I can go back a step and figure out my x, and then go back 2 steps and figure out z. I put it in here. I know x is 1. And it really doesn't matter which one you put these back into as long as you kind of work your way gradually back. So I might put it back into the top one up there. X plus y plus z equals 0. So z ends up being 2. Okay? Alright, so you guys have the rest of the time to work on homework. Realize we do not have AR tomorrow, you have ACP. Yes,
P or T?
ACP.
P?
I know, no, ACT. ACT.
I don't remember the difference.
Because I think we're doing some sort of online test or something.
Oh, to finish them up.
Yeah.
Okay.
Yeah, I didn't.
Yeah, I did.
Maddie, imagine having to do any of these.
Alright.
No.
Alright, again, sorry for forgetting about you guys.
Huh?
Didn't you have to finish that?